Hi, it's for me a pleasure to be here. Thank you for coming. I'm going to talk in the next minutes about my experience in trying to grow data scientists in an academic institution. Well, it worked before, I promise. Okay. This is Gartner Hype Cycle about data science. If this works, well, you can see there, data science is about reaching its peak of inflated expectations. So we must take care of this when we talk about data scientists. Big data, however, has already passed the peak. It's expected to reach a plateau in 5 to 10 years, while data science is expected to reach it in 2 to 5 years. However, data scientists are a very interesting profession right now. As you can see, the average income is very interesting. In Spain, not as much, but we are in a huge economic crisis. And the number of data scientists that are expected to be hired in the future in Great Britain or in the US in the very near years it's also huge. But what is a data scientist? I have seen many videos and heard many different definitions. I think that the powerful trio of maths, computer science, and domain expertise, it's a good definition. And sometimes some of them is forget, and the others are emphasized. But I think domain expertise is very important. And sometimes we forget this. A lot of times we forget this. We, as data scientists, not only should be able to understand the users about the technical details of their fields. We need to understand what they need so we can deliver them what's required. I'm going to make a little parenthesis and tell you about my little history on this. I arrived to Coruña in 1990, and at the time, my research interests were on knowledge engineering and intelligence monitoring. I'm telling you this because I think that knowledge engineering was for me a very good train. Because as a knowledge engineer, I was accustomed to talk to other different professionals from different fields and try to interpret what they need. Our graduates have programs on computer science, computer engineering, and software engineering. And after a couple of years of arriving to Coruña, we started to work with data. We started to mix between the knowledge-based approaches, the symbolic approaches, with the knowledge that we could derive from data. So that is our main train. In 2007, we started to work we found some data sets that were of interest for us because they were what we called high-dimensional data sets, too big at the moment. Now they are tiny data sets. And the problem was that the machine learning methods that we were using had problems with scalability and efficiency, and we tried to develop new methods, new classification, prediction, and anomaly detection methods that were scalable. A year and a half or so after this project, which was a theoretical project, a company came to us and asked us to try to develop a profile of their users who were users of a digital newspaper. That was our first contact with real big data from the real world. And we didn't knew it yet, because at that time, nobody was talking about big data, and nobody was talking about data scientists. But we were on our search for the unicorn, the perfect data scientist. And what do we do to have them? Well, as I said, maths and machine learning are the base for us, so our students need to learn and be updated on the different languages, tools, packages, and machine learning methods that are arising in the field. But we emphasize very much also the expertise, the knowledge domain. This is something that's not teach, but needs to be learned if you want to, if you would like to be a data scientist. And of course, they know how to code. And at this point, I would like to make some reflections on this. I think that we have an important advantage in academia, is that we can try before we buy. That means that we don't need to hire a new person, a new student. We can start working with him or with her when she is doing his or her final project. And so you can see if the person likes the work, and at the same time that you empower him or her in learning technical capacities. There are a couple of things that I think are very difficult to teach them, because we don't teach this in the graduate school. It's communication capacities, how to talk with another professional from other field and try to understand what the person needs, what is telling us. And also, it's hard to work on the writing and speaking abilities. This is something that we don't teach at graduate school either. So they don't know how to, very few of them, know how to write a scientific report. They do how to write a user's manual, but not how to do a paper. Or, and they have problems when try to make an exposition of their work. Visualization is also a type of tools that we don't teach very much at school. And it's something that I think we lack in the field of machine learning. We are always trying the machine to do everything, and we forget that visualization tools can be interesting, and so we can offer a visualization to the human who can do her part, which is also important. Another thing that we have learned is to clean the data. Preprocessing data is very important, and sometimes, many times, we don't talk about this. Of course, when the students come, and in our theoretical projects, the data is perfect. In fact, most of the times we work with benchmark data. So nothing happens there except the difficulty of the work that you are doing, but there is no problem with the data. But when you talk with a company, with industry, they give you data, and that data has not even been thought of for being used for anything, anytime. So we have a lot of different problems, like missing data, we need to discretize data, we need to normalize data, we need to denoise data, and so on. This is a task that takes a lot of time, needs a lot of knowledge, and needs a deep understanding with the people who gives you the data. The data is not something that can be just leave there and treat as numbers. Data means something, and it's important to have knowledge about it, to work adequately with it. I have borrowed this transparency from one of the New York talks in Strata. So we have maths, we have engineering, we have writing capacities, which is important. There are two other things that we need. We need skepticism and curiosity. Skepticism is difficult sometimes. The students do not like to criticize their own algorithms, for example. So you need to push them to try to pursue future work, to find the weak points of their algorithms and try to make them stronger, go further. And if you want to be a good data scientist, curiosity is very important also. Make questions is very important. Another thing that's important, at least for me with my students, is trust. Anytime that I have someone new, there is a trust contract between that person and me. I believe that this person will work doing things well, of course with supervision, and the person needs to believe that I will be there to help. And to do this, you need to work on the positive aspects, but mainly on the negative ones. And this is difficult when you need to manage a team, because trust is something that must be transmitted. So if we don't trust one another, work can be an uphill slog, and the productivity of the team gets diminished. Another reflection that I have made, well, if you want to be a good data scientist, you should be updating your knowledge all the time. You need to learn new techniques, new tools, new data sources. What happens in academia is that our data scientists grow very slowly because they are with you in projects that have several years in duration. And when they are at their productivity peak, they leave because they find magnificent jobs in the industry, which is perfectly fine. I mean, for them it's fantastic, for the industry it's fantastic. We transmit the knowledge and make transference of the know-how, but for the research team it's a tragedy, because you need to start it all over again, and the knowledge goes with the person. So you must be updating yourself all the time. Another problem that I think we have in academia and in several companies that I know is diversity. We are not accustomed to incorporate diversity in our teams. So most of the times we have teams only with computer scientists or only with mathematicians, and diversity is key driver for new ideas. This is important, and we forget this frequently. A couple of things more is that, as we can see there, the profile is complex and is getting more and more complicated. So most of the time, it's impossible to have all this knowledge in just one person. For example, the European Data Science Academy, EDSA, is working now on the recommendations on new curricula, especially for masters. And they recommend interdisciplinary curricula with a special focus on high-impact applications. For example, like, I don't know, bioinformatics, astrophysics, and so on. And several profiles. One profile more devoted to the data analysis part, other who are more devoted to the data engineering part, people who can work on the storage and management of data, and people who are more in the bridge between the technical part and the business and application profiles. So probably in the next future we will be working on these new profiles in academia. And just a couple of things more. For me, I think it's important for our group in the university, it has been very important to work with industry. And this is sometimes problematic, despite the fact that most universities, like mine, had created centers for ICT, like, for example, ours, which is CITIC, in which all the groups related with ICT cohabit. So we can work in the different types of organization any data science organization can work. I mean, we can work as a service, for example, when a company comes and asks CITIC to make a project. So CITIC checks which are the research teams involved in that and contacts you. We can work as embedded in business because we can work as an isolated research group, and contact another research group that can work with us in a specific aspect that we are interested in. Most of the times we used to work as a hub with teams. For the different projects, we make different teams, and we try to rotate so people can learn from different aspects of data science, except in the case of the PhDs for time restrictions. And finally, we work also with data democratization. All the data is centered, so all of us can use it for mainly theoretical reasons, for developing new algorithms or new characteristics of the algorithms, of course, unless the data is confidential and cannot be used for other reasons, different from the original ones. And finally, I would like to say that the best ideas, at least in my experience, always came from the interaction between the theoretical studies that we have made, between our theoretical projects and the real projects. At this time in which the research is so, it's not emphasized, at least in Spain. It's not easy to be a researcher in Spain. I think that we must remember that interaction is important. And although if we don't cohabit in the same grounds because universities and industries are not together physically, we must cohabit in our work, because the best ideas, as I say, come from the interaction between both worlds. And that's all. Thank you.